Now let's look at one of the strong arguments for using derived types. Let's imagine that we're going to write a main program. Let's ensure that all of our variables must have a declared type. And we're going to call a procedure that actually is going to do nothing other than demonstrate a case where we have a long list of arguments. Three of the arguments will be real. Two will be integers. Two will be characters. Now, had we instead taken this data and packaged it up in a derived type, we could actually pass all of this data as one argument. Let's say we just want to print out the reals. And now we'll implement these procedures inside a module. We'll have a use statement to bring in the type and the procedures from that module and import them into the main program scope. For both documentation purposes and to avoid any name clashes with other names that we might have in this main program scope, we'll explicitly state what we want from that module. Let's look at how we would implement that type in a module. So we'll open and close the module scope, ensure that all of our variables have to have a declared type. And now we'll define our type. And we'll put these data components inside the type. And I'm going to give each of them a default initialization so that even once they're simply declared, they will have a value. All of its components will have a value. I'll use what's referred to as a deferred length character component. That is a feature that allows me to leave it to the compiler to size this character variable, essentially a string, dynamically based on what I assign to it. And now we can see one more reason for using derived types is that in addition to storing all of the data, we can also store some metadata that says that by default, when this thing first comes into existence, I'm marking it as not yet having been user-defined. So we'll write our do nothing procedure. And as the name implies, this procedure will do nothing other than accept certain arguments. But for our purposes, we don't need to do anything with those arguments. And this simply says I'm not going to define the length of the character variable in this setting Now let's define our print reals subroutine. And in one argument, we're passing in a veritable treasure trove of data. And we're going to print out just the real components. In Fortran, we use the % sign to select off components. We'll also see later how that's used to call procedures that are bound to the type. And let's just print out that metadata that tells us whether or not this variable has been defined by the user. Now let's compile. And let's link the two object files into one executable named y-derived types. And we'll run it. Now we see that we've printed out the 3 real components as well as the flag that tells us that the object has not yet been user-defined, so we're looking at default initialization values. And what this points out is that when we're passing around raw data as a long list of arguments, 2 problems arise. One is the long list of arguments, and the other is that oftentimes we don't have metadata that tells us important information about that data, and that metadata is best packaged up with the data into a derived type to tell us things like this data has not been user-defined.